Okay, moving on to question 10 of the Carbonyl compound tutorial. It's a synthesis question modified from the recent A-level 2022. So we have butanone, a 4-carbon ketone, undergoing a 3-stage process to produce 2-methyl-butanoic acid. Right, so it's a carboxylic acid. Yes, you can see the functional carboxylic acid here. But it also has an alkene because of the EN. Right, so carboxylic acid functional group over here. Then carbon number 1, you have a C with a CH3. The carbon-carbon double bond is between this carbon and this carbon highlighted in green. Right, so it's over here. Alright, so in this case, you can see there's a carbon number 2 here, there's a CH3. And the last carbon is actually a CH3 attached to the double bond. So the question is, what can we then use for this 3-stage synthesis process? What reagents can we use? So one quick look at this question, we have a 4-carbon process, 4-carbon reactant to a 5-carbon product. It's a step-up reaction. It must involve your CN, nitriles, right, your CN minus. So in this case, quite clearly, because we have a ketone functional group only, we must therefore think about what reactions can ketone undergo. Ketone cannot react with corn H2SO4 with heat because it can't undergo any elimination reaction. NaOH equals and heat is also not possible. There is no reaction with ketone. So the only possible reactions are your HCN. So with HCN, what's the product that can form? So let's take a look. With HCN, you have your nucleophilic addition reaction. You basically add a H and CN across the CO double bond. So this is where the CO double bond was previously. You add a H and CN across the CO double bond. Alright, next. Eventually, we want to get to our 2-methyl-butanoic acid. So let's go through C and D because A and B are really obviously wrong answers. So between C in this case, it's likely that we have to do an elimination reaction first to remove the alcohol. Or we can use NaOH to do your basic hydrolysis of your CN to COO minus first. So let's take a look at what's a possibility. So if we do D first, this will be our product we get. So imagine if we do NaOH equals heat under reflux, we get our basic hydrolysis. Your CN now becomes your COO minus. And then followed by H2SO4, corn, heat, we do a elimination reaction. So this OH and the adjacent carbon, this adjacent carbon with the H, this OH and this H can come out. And then you form a double bond. Right, so this is one way, and therefore this is the route of D. Now, if I do C first, what is the issue? Why is C not the correct answer? And why is D the correct answer then? Now, in the case of C, I do elimination first. I can end up with a compound that looks something like this. Double bond. I get my CN. Let me redraw this a bit. So I have CN. The OH is gone with the adjacent carbon, hydrogen. So you have a double bond here. But when I next do NaOH equals with heat, I will not be able to get this compound. Why? Because I end up with COO minus because of the basic hydrolysis. Alright, so in this case, I get COO minus and not COOH, which is what is required by the question, and that's why C is not a possible option. Okay?